Hey guys, so obviously I'm not in class today and I wanted to make sure that I went through some of the notes from section C with you in this video. Couple things. First of all, section C is really just an extension of section B. So we're still talking about slope-intercept form, which is the y equals mx plus b form that we learned yesterday. Now, the only thing that we're adding in is something that's called direct variation. And this is just a special type of equation in slope-intercept form. There's a couple things that are required in order for an equation to be direct variation. And we briefly talked about this when we looked at word problems last chapter. So the first thing is the requirements. You guys, direct variation must include the point 0, 0. This is essential. If we don't have the point 0, 0, then it's not direct variation. The next requirement is that the function is linear. So we can't have direct variation with something like a quadratic function, which is the U shape and so on. And the last thing that this requirement says is that it must be a function in the form y equals m times x, where m is the rate of change, which is what we also will refer to as the slope. Now, this is the same thing as y equals mx plus b, but the b is 0. The b is 0 because my y-intercept is 0, 0. So it's the same thing. Y equals mx plus 0 is the same thing as just y equals mx because it's just there's nothing on at the end. So I don't want us to overthink this. It's just like slope-intercept form with these special requirements. So the first example is using a table of values to determine whether or not something is direct variation. So if you guys look at the first one, you can see, is 0, 0 included? The answer is yes. 0, 0 is included, so that's my first check mark. And then, is it linear? Well, how do I check if something's linear? This requires a little bit more work. We just need to check the common difference of both columns. So this side is going up by 1, plus 1, plus 1. So this side has a common difference, and here we're going up by 4, plus 4, plus 4, so we're good. So since there's both a common difference in the x column and the y column, it is linear. So yes, this is direct variation. Or it varies directly. All right, guys, next one. Right away, I'm seeing, and I'm looking for the point 0, 0, and I don't see it. So this does not include doesn't include 0, 0. Okay. Doesn't include 0, 0, so it's not direct variation. Or it does not vary directly. Okay, last one. Let's check. All right, first of all, I see 0, 0. So 0, comma 0 is a check. Now I check if it's linear. So let's see, we got plus 1. We got plus 1. Plus 1. All right, so my x's are good. Everything's going up by 1, and my y's, plus 5, perfect. Everything's going up by 5, so this is linear, so this is a yes. It does vary directly. Amazing. So that's with the table of values. Now we can do the same thing, but we can do it with a graph. So it's the same idea, you guys, and this one's even a little bit easier. Does it include 0, 0? We call that the origin, and it's very obvious to see whether or not a graph goes through the origin. Does it go through the point 0, 0? The answer for this one, yes. Second check, even easier, is it linear? Well, is it a straight line? The answer is yes. So it varies directly. All right, very nice. Next one. Okay, first check, 0, 0. Well, I can see right here that the blue line is not exactly going through 0, 0, so it does not vary directly. All right, now you guys can go ahead and try on your own. Right away, I'm looking at the first one. Does not go through 0, 0. So this one's a no. Does not vary directly. Second one, yes, it goes through 0, 0. And it's linear. So this varies directly, or it is a direct variation. Last, but certainly not least, again, we do have 0, 0, and this is linear. So this also varies directly. Oops, I forgot to write yes for the second one. There we go. All right, guys, take a look at this page of notes, and we're going to go on to the next page. Last example for direct variation, and then everything else on this worksheet is just a review that I will just very briefly go over. So this is writing equations of direct variation equations. Really, you guys, try not to overthink this. This is going to be the same thing every time. So first they give us a really big clue. Y varies directly with x when x equals 2 and y equals 8. Find y when x equals 13. So what we need to do for this is use the base equation, the formula, which for direct variation is just y equals mx, remember, because there's no b, all right? Or rather, b is 0. So we use y equals mx, and then they give me something really important. They give me an x value, and they give me a y value. So I simply can plug in to my formula. I'm going to plug in 8 for y. I don't know the m, but I'm going to plug in 2 for x. And now I'm going to solve for m. So that's my first step. And right now I'm dividing both sides by 2 because it's m times 2. So to undo times 2, I divide. 8 divided by 2 is 4. So now I know that my slope is m. Okay, so my first step here is find m. Now once I found m, I can rewrite my equation. And I can use m. So my equation is y equals 4 times x. Now before I said 13, and I'm just realizing that x is 13.2. So now the last thing is just to take x and plug it into my new equation. So I'm going to find y when x is 13.2. So we got to do 4 times 13.2, which is 52.8. So now I have found y when x is 13.2. Okay, so my first step was to find m, and my second step was to rewrite the equation. And my third step was to plug in the given value. Okay, 3 steps with these problems. And let's do a couple more examples. and we'll be good to go. Y varies directly with x when x is 4 and y is 5. Let's pause right there. We write down our equation, y equals mx. We plug in x is 4. We plug in y is 5. Perfect. Now we have to solve for m. So we need to get m by itself. It's m times 4. So we're going to undo that and divide both sides by 4. Now we get a fraction here. Don't freak out. That is normal. We're going to rewrite, we're going to rewrite our equation with the m. This is step 2. So y equals, write down your new slope, 5 over 4 times x. And now, last step, find y when x is 7. So we're plugging in x equals 7. So y equals 5 over 4 times 7. Now you could do this in your calculator, or you can just multiply times 7 over 1, which is 35 over 4, or 8.75. I would probably just use a calculator. And it's okay to get a decimal answer. And I'm going to do one more. Y varies directly with x when x is negative 5 and y is negative 10. So we write out our formula. And we plug in x is negative 5. And we plug in y is negative 10. Write everything else the same. And now we're going to solve by dividing both sides by negative 5. So I get m equals negative 10 over negative 5 is positive 2 over 1, or just positive 2. It's positive 2 over positive 1. So now we know our slope. I did the same thing again. Now we know our slope, and we can write our new equation. Y equals 2x. Now this one says find x when y is 14. So now I'm going to plug in, instead of plugging in for x, I'm going to plug in for y. 14 equals 2x. And I'm trying to find x, so I have to divide both sides by 2. I get x equals 14 divided by 2 is 7. So when y is 14, x is 7. And that's all there is to it, guys. Again, 3 steps. Find m, rewrite your equation, and then plug in whatever value they give you and solve for the other one. The rest of this section is just graphing. It's a graphing review, both with slope-intercept and point-slope form. So I'll do one example of slope-intercept, one example of point-slope, and that should be good. We should be good to go. So we talked about this one yesterday. Right away, this equation's already in slope-intercept form. So my slope is always the number that's right next to x. I'm going to write it as a fraction, 4 over 1. My y-intercept is the number on the end, and we don't change the point unless it's in point-slope form. So that should be 0, negative 1. All right, so now I'm going to plot my starting point, which is my y-intercept, 0, negative 1, and I'm going to count my slope, up 1, 2, 3, 4, right 1, up 1, 2, 3, 4, right 1. And I graph my line. Hopefully we're getting the hang of it. I will do another example on the next page. So here we are. And guys, let's just do one more quick example. Slope-intercept form. Again, slope, 3 over 4. Y-intercept, 0, negative 4. So I plot my point. I count my slope. Up 3, over 1, 2, 3, 4. up 1, 2, 3, over 1, 2, 3, and 4. Connect the dots, and I have my line. Again, that was slope-intercept. Now, point-slope is very similar. Very similar. But instead of getting my y-intercept, I'm going to get my point. Remember, we always change the sign of the x, so it's -2, and for the y, so it's +4. That's the only trick. And then we got 1 over 2 for my slope, which is always the number in front of the parentheses. So plot -2, 4, and then count up 1 over 2. Up 1 over 2. And you can keep doing that and draw your line. Last point slope example. My point here is going to be +1 because we do the opposite sign. My y value is -1. And this time my slope is -2 over 1. So I'm going to go down to right 1. Okay. My point is 1, -1. And I'm going to count down to right 1, down to right 1. And there's my line. Beautiful. Alrighty, guys. The last page of your notes is just rewriting into slope-intercept form. I'm going to talk about that for a minute, and then we'll be good to go. Like I said, last example here. So again, you guys, this is just rewriting into slope-intercept form, which means get y by itself. That's all it really means. So that's exactly what I'm going to do. We always start by distributing to the parentheses. So I get 2x minus 2 on the right-hand side, and just copy down the left-hand side y minus 4. Next, I add 4 over to get y totally by itself. So I get y equals 2x, and then -2 plus 4 is +2. And now my equation is in slope-intercept form. And that's all you're doing for all of these. I think number 9 kind of has some interesting answers. I'll do that one. We get 1/3 x plus 4/3 on the right-hand side, y minus 1 on the left-hand side. We have to add 1 to both sides. All right. And we can cancel the 1s, so we get y equals 1/3 x. Now, 4/3 plus 1, I can rewrite 1 as 3 over 3, and then I can just add 4 plus 3 is 7/3. Now, if you don't like doing it that way, you can always use your calculator. You would get y equals 1/3 x, 1/3 x plus 2 1/3, or 2.33. I would accept that, but I really do prefer you to keep it as a fraction. All right, you guys, let me zoom out so you guys can see all of that. But that's really it. So, hopefully this was informational for you, helped you out a little bit in case you were lost yesterday. And that's all I have. So everyone have a very, very, very happy Thanksgiving. And I will see you guys on Monday when we return.